All right. Hi, everyone. How you guys doing? So first of all, a very happy new year to all, everybody. Okay, and so this is our first session of the new year. I hope everybody had a wonderful start to the year. Okay. So first of all, let me welcome you guys to the Unacademy JEE English. This, as you know, is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this particular channel, every concept of physics, chemistry, and maths are being taught to you completely in English. Now, this is the series that I host for class 12 students, and this is meant as a quick review of all the topics before they go on for their JEE Mains examinations in a few months. Okay, so the topic that we are discussing today is thermodynamics. This is part 4 of the quick review. So this is a huge topic. So I have broken this into like 4 or 5 parts. Okay. All right. Now, before we get started with today's session, let me introduce myself for those of you who might not know me yet. Hi, Shivam. आपको भी शिवम. Happy New Year to you as well, family home. So I wish that all you guys have a wonderful rocking year and do well in whatever you're trying to achieve. All right. So loads of love and loads of luck from my side. Okay. All right. So as I was saying, those of you who don't know me yet, so my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years, I've been teaching physics for the IIT JEE Mains and advanced examinations. All this teaching so far had been in offline setups. Okay. Now, as a student, I myself was All India rank 447 and All India rank 192 in the two stages of the IIT exams that I took. I also qualified the NDC stage 2 and I was in the top 1% in the NACP. I've already coached many students to top ranks in the IIT examinations, both the mains and advanced, so far in the offline setups. And now I hope to continue doing that with you guys here online. All right. So, how can you guys make sure that your studies are definitely. Let's hope this year Corona goes away. We are back to our normal schedules. Okay, that has been tough for all of us, right? Just hang on for a second. Seems working fine. Yeah. So here we go. So as I said, in this lockdown, hello Aftab, how are you? So I had to adapt just like that. A lot of students were forced to adapt. So this is one great way of adapting. You can get yourself the Unacademy subscription. All right. I am COVID positive right now, isolated in my room. Oh my God. How did that happen? Wow. So take care, have family home, and I hope you are. Yeah, I hope you're doing fine, and I hope nothing serious. Just take rest, proper rest, and take care. Okay, and I'm sure, hopefully you will get back uh, uh, to your wellness very soon. Okay. All right. So as I was saying, uh, the benefits of the Unacademy subscriptions are as follows. So you get live classes, you get to interact with your educators, you have live polls and leaderboards in these classrooms. Then you have test series and analysis sessions. Oh, all right. No worries, no worries. Just take care, and I'm sure you'll be fine. Okay, don't worry. Okay. Family home vaccine in stock now. Hmm. I know. Let's hope that vaccine comes out as soon as possible so that our lives can finally go back to being normal. I mean, I would love to see my students trend while teaching. Okay, I'm so not used to talking to my laptop while teaching. All right. Anyhow. So again, as an important feature of all Unacademy subscriptions, you have live doubt clearing sessions. So every fourth session in all Unacademy Plus courses is a live doubt clearing session where your all your doubts will be taken care of. So on top of all these benefits, Unacademy subscription gives you another great opportunity to study from the topmost educators all across the country from the comfort and safety of your home. So that's a wonderful chance. Hello ARJ, how are you? Hmm. I want more material on Plus from you, please. Okay. So I already have those courses and I do keep taking special classes. No. Okay. Right. I don't know if that's going to be possible anytime soon. Let's see. Okay. as I was saying, you are getting the opportunity to study from the topmost educators all across India from the comfort and safety of your home. You don't have to come to my home, okay, Shivam. So I know you are from Allahabad, right? And now you can study from Allahabad, sitting in your home from me, who is in Delhi, right? So here you keep following me here, and don't worry, it will be fine. Hello, Ashwin, how are you? So all right, for as I was saying about the Unacademy subscription. So one great way of getting started is to get the subscription. And how to get the subscription? The first step would be to install the Unacademy app. Okay. The moment you install this app, you already unlock a lot of features for yourself. So you have some free courses which you can simply join just after installing this app. Okay, and then you have special classes which all teachers, including myself, we keep taking. Okay, on a regular basis. So at least 2 to 3 classes in a week will be there, at least by per teacher. Okay, you can attend classes of any teacher, and these are absolutely free. All you need to do is just install the app and you're done. And then you have quizzes, so you can already utilize all these free features. So these are all free, no subscription needed. Okay, for getting these, all you need to do is just install the Unacademy app. Okay, so RJ says I'm only having tensions and I'm confused now. Okay, don't worry, yeah, ARJ. Everything will be fine. Just stay focused on your work and be positive. That's about it. Okay. All right. So this is how you can avail all these free features. Now, if you like all the free classes and the free courses, and if you think you are ready to get yourself the finally the plus subscription, then this is how you do it. You can go to the plus segment of your app, select your goal as IIT JEE, and click on that get subscription button. Now, when you do that, you'll be redirected on the payment page where you can definitely remember to put this code RD Live. So this code will give you a 10% off on all your subscription fees. Okay. Now you can choose from plus subscription or the iconic subscription, and once you click on proceed to pay, you will be RDSC or RD Live. There are two vaccines for this tension virus. Okay. Use code RDSC or RD Live. Both will work. Don't worry. All right. Anyhow. So when you click on proceed to pay, you will find you also have a lot of no cost EMI options to make those payments. Now you can also go for the iconic subscription. This subscription will take your IIT JEE preparation to the next level by assigning you personal coaches and by giving you these benefits. Okay. Now there is something new. Okay. So Unacademy is now providing you combo subscription packages. Okay. So now you can choose a combo of iconic subscription for IIT JEE, plus subscription for CBSE 11th, and plus subscription for CBSE 12th. So all these three have been combined together and you have one combo subscription. Similarly, you have another subscription where you get all three iconic. Then you have two more where you get all three plus, or IIT JEE plus and iconic 11th and 12th. So these are all the combo offers. So as the prices are mentioned here, so this starts at roughly 4,700 a month. This starts at 5,500 a month. So this starts at 3,000 a month, and this is at 3,900 a month. So with these combo offers, all your queries, all your worries of 11th, 12th, and JEE are sorted. Okay, so you can go for these. 2021 tension virus, absolutely. I can completely understand. JEE questions में maths and physics involves some 11 stuff like say maybe sequence and series and matrices, maybe center of mass and electrostatics, etc. I'm confused about this. Okay. So yeah, I mean, once you have done all the topics, then you can try again. Okay. So the problem is that we are left with only few months, and for a couple of months, the prices are really high. And I'm glad enough we have this YouTube live sessions, and students are less here also. Our doubts can be cleared here only. Yeah, absolutely. So this subscription again is for somebody who would be entering class 11 now. No, so for the next 2 years, who's looking for. So when a person like you, family home, can even go for a smaller subscription. So there are all sorts of subscriptions. There are 3-month subscriptions. There are 6-month subscriptions. I mean, it's up to you. And of course, you have the chance of studying absolutely free of cost here also. Okay, but these are mainly for class students who are just entering their class 11th and who have another 2 years to prepare. Okay. Next, again, you can even win yourselves these subscriptions and other rewards by taking part in the Unacademy Combat. Okay. So the next event is going to happen on the 3rd of January. You can enroll now using the code RD Live. So this will not only be able to help you test your knowledge, test your understanding, test your preparation, test your standing amongst your peers. A lot of people would participate, so you will get to know your ranks amongst your peers. And of course, if you do well, you will win some really cool prizes also, including a lot of Unacademy subscriptions also. Okay. All right. So yeah, this is my math teacher last year was so amazing. She somehow managed to prove 2 equals 0. Okay. Okay. I don't know whether that was intentional or not. Okay. Intentionally, I can prove sometimes 1 equals 2. Okay. I can do that. Trust me. I can also have some fun with maths. Don't worry. Maybe in some free time I'll show you. Okay. Again, those of you who are following us on the JEE English channel of YouTube can connect with us on the Telegram app using this link, so that you are aware of all the sessions and lectures happening here on this channel of YouTube. Okay. Now, okay, finally, let's get started. Let's get started with today's discussion. This is part 4 of quick review of thermodynamics. So today we'll start our discussion of first law of thermodynamics. Okay, so what does first law say? So before we discuss the first law, let's go over some basic definitions. So first we will define a thermodynamic system. A thermodynamic system is a body of matter confined by in space by some walls or boundaries which separates it from the surroundings. So you have a system defined which has some boundaries to separate it from everything else, which is called surroundings. Okay, happy new year to you as well, Lokesh. How are you? So good to see everybody. Okay, have an amazing year, guys. All right, let's hope all of you guys rock in this new year. Now, these systems can be of three kinds. So there is an open system, there is a closed system, and then there is an isolated system. So what is open system? So imagine gas in a container which has its lid open. Okay, so such kind of system can exchange matter and energy both with surroundings. Okay, so that's the characteristic of an open system. Okay, so can exchange both matter and surrounding, mass and that is mass and energy from its surroundings with surroundings. So that's an open system. Then you have closed system. So closed system can exchange energy but not mass. Okay, with surroundings. So something like another container, but with a lid over it, but let's say a metallic lid. So across which you can exchange heat, but you cannot allow the matter to escape. Okay, so that's okay. I have no idea. Okay, I don't know how you would define that. So I don't know anything that is kept in the open. पानी का glass, हाँ एकदम एकदम. पानी का glass is an open system. Okay, so we are talking about gases, by the way. Okay, here we are talking about gases. Okay, now you have an isolated system. Isolated system is one in which you have boundaries which do not allow any kind of exchange with the surroundings. So neither matter nor energy can be transferred between surroundings and the system. So no transfer of mass or energy is allowed. Okay, so that's an isolated system. Okay, smoke. I don't know, that probably would be open system, no? Open system, because you are exchanging energy and mass both. All right, now let's go over some other basic definitions. So we define something called a thermodynamic state. So what is a thermodynamic state? So if you have any gas sample, so we can assign a thermodynamic state for that sample in a particular state of by defining its temperature, pressure, or volume. Okay, so thermodynamic state of a system is a condition at any specific time. So at any specific time, the state of the gas can be defined by using these parameters. These are known as state parameters, which are P, V, and T. So if you define this, the pressure, volume, and the temperature of a gas, we say that we have defined a thermodynamic state. Now we have thermodynamic processes. So what is a process? So when you change the thermodynamic state of a gas from, let's say, state A to state B, then whatever path you take while changing this state of the gas is known as a thermodynamic process. Okay, so let's say if you have a PV graph, you realize any point on a PV graph, this is a thermodynamic state. Any point on PV graph would be a thermodynamic state. Why? The moment you have a point, you have defined HP, you have defined HV, and you know from PV equals nRT, the T is automatically fixed. So the moment you fix two variables out of PV and T, the third one automatically becomes fixed. So every point on a PV graph or a VT graph or a PT graph will essentially define or represent a thermodynamic state. Okay. Okay, Shivam, I have no idea. So let's stay focused. Okay, I understand. I understand you're feeling excited about the new year and everything. But trust me, you don't have too much time to waste with, you know, it's just stay focused. Okay. So as I said, every point on a PV graph or PT graph or a VT graph represents a thermodynamic state. Now imagine if you wanted to change the thermodynamic state. Let's say if you wanted, you had a gas which was here, initial thermodynamic state was some A. Now if you wanted to change this thermodynamic state to B. So how do you do that? You could have taken it along many paths. You could have taken it along this path which is shown. Maybe you could have taken it along this path. Okay, maybe you would have taken it along another path, maybe like this. So all these lines, all these paths that you follow from starting from A and reaching B. So every path is what we call a thermodynamic process. Okay. So again, it is the path through which a thermodynamic system is taken from its initial thermodynamic state to the final thermodynamic state. Okay. Now let's talk about the first law of thermodynamics. The first law of thermodynamics is essentially a result of conservation of energy. Now what it says is that imagine heat, is a form of energy. So what it says is if you have a system, okay, where you have gas and if you provided energy in form of heat, okay, now there are two things that this guy can do with that heat. So I mean imagine of this as your parents giving you money. So when your parents are giving you money, you can do two things with that money. You can either spend it or save it. So that's what this gas can do with the amount of heat energy that it is getting. It can either spend it in doing work around the surrounding. So maybe it pushes the boundaries, it expands and it spends it in expansion or doing work. Okay. Or it may store it and increase its internal energy. Okay, कोई दिक्कत नहीं है यार. All right, thank you so much, Espande. Yes, I saw that. And Happy New Year to you as well. Okay, all right. So as I said, so what it says is that when you give it energy in form of heat, now there are two options for the gas. It can either spend it in doing work or it can store it in form of internal energy. Okay, now obviously because of conservation of energy, so if your parents gave you 100 rupees and let's say you spent 50 rupees and saved 50 rupees, then the sum of the two money spent and saved would be equal to the amount that you got. The same is this first law. This is telling you that if Q heat is given to a system and it spends W amount in doing work and stores delta U amount in increasing its internal energy, then the sum of W and delta U must be equal to Q. Okay, remember. So that is what this law is. So this law states that when a thermodynamic system is given heat, some part of it increases the internal energy of the system, and remaining part is used in doing work by the system. So delta Q would be equal to W plus delta U. Okay, again, heat given to any system can also be represented as NC delta T. If you remember the definition, we had defined C. C was molar heat capacity. Okay, so molar heat capacity, what is that? That is the amount of heat required to increase the temperature of 1 mole of a gas by 1 degree Celsius, right? Or 1 Kelvin. Happy New Year to you as well. Ultimately, energy is conserved. Absolutely. Absolutely. Okay. Now, where C is a molar heat capacity of system and N is the number of moles. So you can always write if you give a system delta Q amount of heat and if its temperature increases by delta T, then those two things can be related by this equation. Now you realize that in case of a gas, the same amount of heat will have different temperature changes. So a gas theoretically can have infinite heat capacities. Okay, remember that. Happy New Year to you as well, Amod. Okay. Yes, Shivam, I got that as well. Thank you so much, guys. Now, first, before we start understanding all these terms, let's talk about sign convention. This is very, very important because in physics, the sign convention is very, different than in chemistry. Do not get confused. So, in physics, heat is taken to be positive if it is given to the system, and negative if it is taken out of the system. So please remember, if you're adding heat to the system, you put a positive sign to that heat. If you're taking heat out of the system, then you put a negative sign to that. Now, then you talk about change in internal energy. So if the internal energy is increasing, of course, the change in internal energy would be positive, and if the internal energy is decreasing, then the change in internal energy would be negative. Now, so you can say that if temperature increases, then you have positive delta U, and if temperature decreases, then you have negative delta U. Now, work is where the difference between chemistry and physics happens. Okay. Now, in physics, the work is taken to be or defined as the work done by the gas. So, work is defined as work done by the gas. So, if the volume is expanding, then you can say the pressure is always acting outwards on the boundaries, right? So if the boundaries are being pushed, so the displacement and the force are in the same direction, so the work would be positive, right? So you can now remember this, that it is positive if the volume increases, then the work is positive. If the volume is decreasing, then you take the work as negative in physics. Okay, and obviously it can be calculated as the area under PV graph. Okay. So we can talk about this in detail also once we understand. We will take up one graph and we will try to see everything. Okay. Will this session have questions on first law? Yes. Yes, absolutely. Family home, of course it will. Okay. So ARJ says, sir, I know I have asked this before, but can you tell me if how I can get 50 plus in physics? Because I can manage 70 plus in the other two. So okay, it's very simple. I think just I hope you've solved your HCV. I think HCV plus PYQ, that is it. If you do this, you should get 50% plus, more than 50 marks in physics. Okay, trust me, that would be good enough. Okay. So let's talk about the molar heat capacities. The molar heat capacity C is the heat required to raise the temperature of 1 mole of a gas by 1 degree. This is the definition. So C is essentially delta Q over N delta T, where N is the number of moles, delta T is the temperature. Now you will realize that a gas can theoretically have infinite heat capacities. Okay, a heat capacity can be defined for each thermodynamic process. Okay, commonly we talk about two kinds of heat capacities mostly. Okay, that is CV and CP. CV is the heat capacity at a constant volume, and Cp is the special heat capacity at molar heat capacity at constant pressure. Okay. So why am I saying all this? That why can a gas have infinite heat capacity? So imagine a PV graph. Imagine a PV graph. Okay, and let's imagine that I am trying to change this thermodynamic state of a gas from, let's say, A to B. So initially, imagine the gas is in thermodynamic state A, and I want to take it to thermodynamic state B. Okay, I told you every point on the PV graph represents a thermodynamic state. So even though this is a quick review, so go a little bit slow. Wherever topic is important. Okay. So that is why I'm taking my time to explain. Don't worry. Okay. So the point is that when I want to take the gas from point A to point B, okay, I can do it in many number of ways, right? Maybe I do it like this. So that is one way in which I could have taken the gas from A to B, right? Now maybe I could have taken it like this. Maybe I could have chosen other parts. Okay, let's say maybe I go like this. So that is another way. Okay. Sorry. So you realize there are infinite processes which are possible, which I can, infinite paths that I can take in reaching from A to point B, right? Now, as I told you, how is the work calculated? Okay, so I don't know if you know this. This is a review class, so I did not explain the work calculation. Okay, so the idea of work calculation, okay, let me go over that also. So imagine you have a sample and then there is a movable boundary. So this boundary can move. Okay. So at any instant, if the pressure of the gas inside is P, so let's say the pressure of the gas inside is P. Okay, so pressure is P, and the area of cross section of this is A. So what is the force that the gas must be applying on this boundary? I will say that the force applied F would be equal to P times A. Right now, if this boundary shifts, a bit, it goes from here to here. Right. So imagine if it shifts by small amount dx. So you know what is the work done by the pressure? Again, we are discussing the work done. We are defining the work done by the gas. So work done by the gas, you guys would know is dw is f dot ds integral. Correct. I can say that. Now you realize f is p times a and ds is dx. Correct. Now, interestingly, what is this? Think about this. What is this part? This is A times dx. A times dx is essentially the increase in volume. Okay, A was the area of cross section, dx is the amount by which the boundary moved. So yes, absolutely. So this becomes integral of P dV. I can write this as the integral of P dV. Now mathematically, you know, integral of P dV is nothing but the area under PV graph. Right? If you have P here, if you have V here, then integral P dV is area under PV graph. Right? This is what is integral of P dV. So that is why I was saying that the work done by a gas is the area under the PV graph. Okay. So Sai Teja says, sir, how much time did you take to complete class 11th? And small doubt before board exam or after board. Okay. So for class 11th. So see, first, uh, I was doing only at school studies. Okay, I did not prepare for IIT during my 11th and 12th. Okay, maybe some self study. I used to solve HCV on my own. Okay, and I would just study on my own. I was studying only in school. So 11th, I did in my 11th only, and then after my 11th and 12th, I took 1 year drop. So in 1 year, I took a drop, and in that time, I studied both 11th and 12th for JEE. Okay, so that is the amount of time that I had taken. Okay, but then I had my basics all right. So all I had to do is build up on them. Okay, so I had taken care of that in my class 11th and 12th. I would try to be thorough with my basics. So I had my basic ideas fine. I did not maybe have a very good advanced level understanding in class 11th and 12th, but my basics were pretty decent. Okay, so in 1 year I could build up on it and get to a very good in-depth understanding and a J advanced level. Okay. Yes, so I did work like hell in that 1 year. In that 1 year, trust me, I worked as hard as I could. I never missed a single class in the entire year. It did not matter whether I was well or not, whatever was happening. Okay. Ah, okay. All right. So, okay. So again, what are you looking for? Are you looking for the entire class 11th in detail or a quick revision? Yeah, got that. Or are you looking for a quick revision? So I took this revision series year, last year, yes. So in 2.5 months, I completed all the 11th revision. I think, yeah, 2 to 2.5 months. I think 2 to 2.5 months I took for the entire class 11th revision. Okay. So if that is what you want to know, okay, and that is going to be the aim this year. This time also we started this revision series, quick review series in December. So in 1 month we have already covered kinematics, Newton's laws, momentum, work power energy, rotation, fluids, gravitation. Okay. Yes, revision it is possible. Revision is definitely possible, but I'm hoping you're not looking to study from scratch. Okay, you should already have the basics, and you're only looking to revise. If you're looking to revise in 2 months, you can revise the entire class 11. Okay, I remember when I started teaching. So after IIT, I went into corporate jobs. Okay, for 5 years I was working in corporate MNCs. Okay, then I decided to start to teaching. Okay, and when I came to teaching, I had almost forgotten all my class 11, 12 physics. Okay, so trust me, it took me 2 months to revise the entire class 11. Okay, so it's definitely possible. In 2 months, I was teaching. Okay, from not being in touch with physics for like 5, 6 years. Okay, so yeah, that is definitely possible. All right. So as I was saying here, if we talk about this, what you realize is that let's consider these three processes only. So for these three processes, what you will realize is that if you talk about the work done, so for this process, the work done would be this, correct? This is the area under the PV graph for this process, the green one, right? Now, similarly, for this purple one, the work done would be the area under this graph. So it will be this entire area, correct? This plus this. Now, for the upper one, again, you have this additional area also. So this is the work done. So what you realize is for every different process, the work done is different. So we say that work done is a path function. Work done depends on the path. Okay, work is a path function. Okay, work done by a gas depends on the thermodynamic path. Hello, Thakur Yashashri Rana, how are you? Last chapter of class 11th. No, we still have SHM and ways to go. Okay, so trust me, by the end of this month, we will be done with the entire syllabus of class 11. So it would have taken just 2 months for revision. I'm only left with revision of modern physics. So that's great. That's great. All right. Okay. All right. Again. So work is a path function. It depends on the path taken or the process taken. Now, however, how about the delta U? You know that delta U, however, is defined as n f by 2 r delta t. And you realize this depends on delta U depends on the initial and the final stages. The initial and final stages. So I say that delta U is a state function. Okay. The change in internal energy depends only on the change in thermodynamic state. So for all these processes, you realize whether I take this process, okay, let's call these processes 1, 2, and 3. So this is, let's say, 1, this one is 2, and this process is 3. So for all these processes of 1, 2, and 3, delta U is the same, right? Delta U is the same, but W is different. So what you realize is that for all these processes, you realize you have different delta Qs. So delta Q equals path function because delta Q is sum of W plus delta U. This is fixed. This is same for all processes. Okay. Now this is different for all processes. Correct. So obviously the sum would be different for all processes. Correct. Now if the sum is different for all processes, so I realize for the same delta T, I can have different Qs. In fact, since I can have infinite thermodynamic processes, then I can have infinite values of Q for the same delta T. So same delta T, can be achieved by giving it different amounts of heat. So that is why I'm saying that this would have different values, different for each process. Correct? I hope you understand the logic. And that is why I'm saying a gas can theoretically have infinite heat capacities. You can define one heat capacity for every function or for every process that you take. Okay. So one for every process can be defined. We commonly talk about two kinds of heat capacities. That does not mean a gas has only two capacities. Okay, we commonly talk about CV and CP, but a gas can have other heat capacities also. In fact, it can have infinite heat capacities. Good evening, Sujit. How are you? Okay. Now let's talk about some common thermodynamic processes. First, we'll be talking about isochoric process. Isochoric means constant volume. So this is a process in which the volume of the gas is considered to be constant. So if you look at the PV graph, it will look like this. So thermodynamic state A to B, we are moving along a constant volume line. So the volume is same. So this will be a straight line, right? So the area under the PV graph, of course, is zero. So the work done by the gas in this process is zero. Now, how about delta U? Delta U, we know by definition is 1 by 2 NFR delta T. So if you don't know this, you can watch the previous lecture. Okay, in this previous lecture, I have shown the derivation of this expression also. Okay, now of course Q would be this. Q is defined like this in terms of the molar heat capacity, where CV is called the molar heat capacity at constant volume. Now from the first law, this would be equal to this plus zero. Okay, from the first law, this will be equal to delta U plus W, and W is zero. So I can say NCV delta T equals this. So what you realize is CV for a gas is 1 by 2 FR. Okay, now delta U can also be written as NCV delta T. Now, since the degrees of freedom are already fixed, so I know CV of a gas, CV for a monatomic gas, how much will that be? That will be 3 by 2R. CV for a diatomic gas will be 5 by 2R. And CV for a triatomic gas would be 3R. Okay, F by 2R. So just remember that. This is what you want to memorize. Okay, that CV is always equal to F by 2R. Okay. So this is all you need to know about this process. In this process, the work is zero. The change in internal energy is obviously, we can now call it NCV delta T, and CV is the molar heat capacity for this kind of process. All right, moving on, let's talk about the isobaric process. This is a process where the volume is kept constant. Pressure is kept constant. Okay, so you realize on a PV graph, this looks like this. Okay, you can see here from you're taking the gas from thermodynamic state A to thermodynamic state B along a line parallel to the x-axis. So a constant pressure process can be represented like this. Now you realize the work done can be written as P times delta V because P is constant, and P times delta V can also be written as NR delta T. Okay, I hope you realize that P1 V1 will be equal to NR T1, and P so PV1, let's say PV1 would be equal to nRT1, PV2 would be equal to nRT2. So you realize this is what? PV2 minus V1. Okay, so that will be nRT2 minus T1. So that is why I'm saying that the work can be calculated as nR delta T. Now the change in internal energy obviously will be given as this, and this we know I can also write this as this. Okay, as I said, the change in internal energy is a state function. So it doesn't really matter how the change in temperature was calculated. Imagine if the same change in temperature was calculated by moving through an isochoric process. Then if the internal energy changed by delta U, then for the same change in temperature, the change in internal energy would be the same even if the process was isobaric or the process was adiabatic or any kind of process. So since it's a state function, so we always can write delta U as NCV delta T. Okay. Now Q in this case is written as NCP plus NCP times delta T, where Cp is called the molar heat capacity at constant pressure. Okay. Now from first law, I can write that Q equals W plus delta U, so which will give a relation between Cp and Cv. This is called Meyer's equation. Okay, please remember this. Now, please be very, very careful. CP and CV are molar heat capacities. IIT Mains had asked this question. They said if CP and CV are specific heat capacities at constant pressure and constant volume, then what is the value of CP minus CV? So, but there they said CP and CV are a specific heat capacity. Now, please note here it is molar heat capacity. This one here we use molar heat capacity. So, obviously, the answer would not be R. To be very careful about this. Okay. All right. So, Ethan says, Sir, Anyan sells four books. Three of Irodov, that is General Physics, Mechanics, and Electromagnetism, and one book of S.S. Krutov. Which one should I buy? Just buy one. Problems in General Physics. That is the only relevant one. Krutov questions are not very relevant for JEE. Krutov has more abstract questions, probably more relevant for Olympiads. And the two theory books of Irodov, of Mechanics and Electromagnetism, they are mainly meant for graduation level. Okay, so the maths that they will be using would be not something that you are familiar with. Okay, so you will have a tough time following the mathematics used in that book. Okay, I have studied them all, but trust me, those are not meant for students. Okay, because you won't be able to follow the maths in that. So that's not really helpful for you. Okay. Hmm. Now, so please remember, yes, M times R would be the answer. That is how you can relate molar heat capacities. Yes, yes, only problems in general physics. Here, okay, this is not the Arihant edition, but I have this very old edition. This is 2000 edition. So before Arihant recently came out with this is what I had in my time. This is what I studied when I was preparing for JEE. This is year 2000 edition. Okay, so this is what I bought in my, I think, class 11th. Okay, in the year 2000. I somehow had it saved. Okay, so I could find it in the entire junk of my book collection. Okay, so this was one book that I kept with care. Okay, because this was one of the best books ever. J Advanced 2020 from this lesson is very basic question, sir. Sorry. I'm not sure I follow you, Devra Varun. All right. So again, as I said, when you're talking about this, specific heat capacities are given. So specific heat capacity would be molar heat capacity. Molar heat capacity has molecular mass in it. So it would be molecular mass, specific heat, molar heat capacity divided by molecular mass. That would be your specific heat capacity. Okay. So yes, I think Family Home answered this correctly. M times R would be the answer. Okay. All right. Now let's move on to the next process. The next process that we are going to talk about. Okay, so no, this keeps hanging. Yeah, it's fine now. The next process that we are talking, I have solved Erudov mechanics and electromagnetism. It's a good book. Yes, it's a wonderful book. It's a wonderful book, especially if you want to make your concepts really strong. So basically, the idea is you get a knack of tackling tough situations. So I think that only comes with practice. Knowing the concepts is one thing, and understanding their application will come through practice only. The more you practice and the more difficult situations that you analyze and practice, the more open your brain will become. You will develop an approach. You will develop the idea of how to tackle those tough situations. So I think for JEE Advanced, it's a wonderful book because JEE Advanced would have questions on that level. Okay, all right. So again, let's talk about isothermal process. So isothermal process is one in which the temperature is constant. Okay, so T constant. All right. So the graph PV graph of the isochoric process looks as shown. Okay, this is the graph here. So what you realize is here the work is positive. Why? Because the volume is increasing. Okay, volume is increasing. We are moving. in the forward direction on along the v axis, so the volume work is positive, and work obviously can be calculated as integral of p dv. Right. So now let's just quickly tell you this also. So you know PV equals nRT, right? So what we do is that we can write P as nRT over V. So when you are finding integral P dV, you can replace this value of P. So you can write nRT over P, over V times dV. So when you integrate this from V1 to V2, where V1 is this volume and V2 is this volume, so what you will get is this result. nRT ln V2 over V1. Okay, now the change in internal energy obviously is zero because delta T is zero, as delta T equals 0. Okay, so how about the molar heat capacity? If for this process I wanted to uh, define molar heat capacity, ray optics important for mains? Yes, ray optics is an important topic for both mains and advanced. Of course, of course. They ask a lot of questions from ray optics. Okay. Okay, so Ethan says, sir, also my school is doing a 11th revision for us. The chemistry sir told for thermodynamics. I need to know partial differentiation equations. Is it really necessary? No, not really. Not really. For thermodynamics, why do you need, what kind of partial differential equations is he talking about? I don't know. I am taking this review. Did you see any need for partial differential equations? Okay, I don't think so. Not here, not here. You may even need that for maybe electrostatics. Where in electrostatics, potential and electric field are related by with the help of partial differentiation. Okay, partial differentiation is something very easy. Okay, that is nothing. That is nothing. Okay, I'll tell you maybe in some other class, not this one. Now you realize for this, the C is infinite for this kind of pressure. Yes, exactly. For potential energy and force, you need that. Not for thermodynamics. You don't really need for that in thermodynamics. Okay. Okay. So here in this process, you realize delta T was 0. So you could have said C is Q over N delta T. So you realize since delta T is 0, so this becomes infinite. So the molar heat capacity for an isothermal process can be defined, it would be infinite. Because no matter what amount of heat you give to the body, the temperature is never going to rise. So theoretically, I can say that the molar heat capacity has become infinite. Okay. And Q obviously from first law will become like this. From first law, I can say that it would be sum of work and delta U. So for any change in thermodynamic state, the Q in isothermal process would be defined like this. Okay. Next, you have adiabatic process. So adiabatic process is one in which the mathematically the pressure and volume vary like this, such that PV to the power gamma is constant. Okay. So this is a process where Q is 0. You are not allowing any heat to get exchanged between the system and the surroundings. Okay. So that is what adiabatic process is. It has been noticed experimentally. We saw that this kind of process follows the mathematical equation of PV to the power gamma equals constant. Now you realize work done here is calculated like this, okay, which is nr delta T over 1 minus gamma. Okay, and since Q is 0, so delta U is minus W. Okay, graph problems in thermodynamics are famous in JEE Mains. Yes, yes, yes. In thermodynamics, they ask a lot of graph problems. So you should know how to make these graphs. Okay. For an adiabatic process, this is how the graph looks. Okay. Now, how did we get W like this? So let's talk about that also. Since I know PV to the power gamma is constant, so let's call it some K. So from here, I can say P would be equal to K times V to the power of minus gamma, right? So I know W is integral of P dV So I can just substitute this value of P, and what I'll have is PV to the power of minus gamma times dV integrated from V1 to V2. So this would have given you uh, K times for minus gamma plus 1 over minus gamma plus 1 from V1 to V2. Correct? So when you would have substituted, you would have gotten 1 over 1 minus gamma times, you would have gotten K times V to the power gamma, V1, V2, V2, and minus K times V1 times V1 to the power gamma. Now minus gamma. Now again, you would have substituted this value K times V2 to the power minus gamma and K times V1 to the power minus gamma as P2 and P1. Okay, why are you confused? Why are you confused? It is very simple only. Don't worry, don't worry. Just practice a few graphs and trust me, you'll be fine. So you realize that this term can be written as this is nothing but P2, right? From here I can say 2 would be equal to K times V2 to the power minus gamma, and similarly P1 would be equal to K times V1 to the power minus gamma. So when I substitute this, I have this form P2 V2 minus P1 V1 over 1 minus gamma. And now you know P2 V2 minus P1 V1 will be nRT2 minus nRT1. So I can also rewrite this as this. So the work done comes out to be nR delta T over 1 minus gamma. Correct? This is what work done comes out to be. Since Q is 0, so you can say that Q will be equal to minus W2. So you realize C for this process is 0. Why? Because you can increase the temperature without giving any heat. Okay. So the C for this process would be 0. Okay, remember that. Now, what you can also realize is that since delta U equals a minus times W, okay, so I can also write this. So let's see. Pen has stopped working. Again, let me just give me 1 minute. Yeah. So from this equation, from this particular equation, what I can see is let's add a page. Right. So since W delta U plus W equals 0, so I can say delta U equals minus times W. Now delta U can be written as N CV delta T, and we already realized how is W calculated. W was minus times NR delta T over 1 minus gamma. Correct. So what you will realize is that now CV you also know CV was F by 2R. Correct. So what I can say is I can rewrite this as N F R delta T by 2, and this will be equal to minus times N R delta T over 1 minus gamma. Correct. So you can cancel out NR delta T's, and what you realize is that if you take this here, gamma minus 1 equals 2 over F. So from here, what you get is gamma equals F plus 2 over F. So that is an important result. Okay. Now you know the gamma for any kind of a gas. Okay. Gamma for monoatomic, how much will that become? Gamma for monoatomic would be 5 by 3. Gamma for diatomic, that would be 7 by 5. And gamma for triatomic, that would be that would be 8 by 4 by 3. 8 by 6, so that will be 4 by 3. Okay, so that is what you need to remember. This is important. If you remember this, now you can calculate the gamma for any kind of a gas. Okay. Okay, so Devra says consider 1 mole of helium gas enclosed in a container with initial pressure P and volume V. Expands isothermally to volume 4V. After this gas expands adiabatically and its volume is 32V. Okay, so yes, so what about this? So first it went isothermal expansion and then it underwent adiabatic expansion. Then, so what about this? So it's good that you're asking a query. I will just immediately solve this and let you know how to get that answer. Okay. Now you will also realize one more thing. One more thing. So CV was F by 2R, and what was CP? CP was CV plus R. So I can say CP equals F plus 2 by 2 R. Correct. So what you realize is CP over CV. P over CV is F plus 2 over F. Okay, which is essentially gamma. You notice from here. So you realize that CP over CV is gamma. Okay, so gamma is also defined as the ratio of molar heat capacity at constant pressure and molar heat capacity at constant volume. The work isothermal is to work adiabatic is F ln 2, then F is. Okay, so Devra has asked the question, so let's solve that one. How do I add a page? I add it directly. So add from here only. All right, let's add a page and let's answer Devra's query. Okay. So why don't you guys try this? So you have been told that 1 mole helium, 1 mole of helium is expanded from V to 4V isothermally, and then 4V to 32V adiabatically. Correct. So that is the question. So now Devra wants to know if W iso over W adiabatic is, sir, sure, F times ln2, find F. So that is his question. Okay, so why do you guys want to give it a try? You guys want to give it a try? I think it would be good practice. Okay, how about family home? Why don't you give this a try? Family home and others who are watching, just give it a try and let's see if you can answer. And then I'll show you the solution. This is very simple. I've told you how to calculate the work in isothermal process, how to calculate the work in adiabatic process. Yes, please. All right, let's have it. Hmm. Okay, so let's get you guys some practice. So I've already discussed all these processes. So Devra, so in case you missed it, you will realize for isothermal, this is how you do calculate work, right? This is the work done by isothermal. This you can calculate. Okay. Now you know this is the work done by adiabatic process. Work done in adiabatic process is this. Using both these, you can get the answer of this. See. देखते हैं भाई. Let's see if you guys can get this done. Okay, so initial pressure is also given to you, P. Initial pressure is also given to you. Okay, so You guys can give the answer in terms of P and V. Try to find it in terms of P and V. Quite good. Happy New Year to you. People study with full attention here. कॉलेज में कुछ नहीं पढ़ाएंगे. हाँ, ये तो है. ये तो है. I keep telling all my students this. कि यहाँ पे हम लोग जितनी एक्सप्लेनेशन देते हैं ना कॉलेज में इसका आधा नहीं समझाएंगे और तुम लोग पूछते रह जाओगे डाउट्स. वहाँ पे टीचर्स वोंट पे हाफ द अटेंशन दैट यू गाइस गेट हियर. सो मेक यूज ऑफ दिस. यहाँ पे जितना सीखना है सीख लो. That had been my personal experience also. I shouldn't probably be saying it on YouTube, but that was my personal experience also. Sir, anyone tells to make a plan, but everyone tells to make a plan, but how that they don't tell. Okay. So again, the reason why they don't tell how to make a plan is because everybody has to plan according to their strengths and weaknesses, right? Correct. So that is the reason. At least I don't like telling you how you should plan your studies. It's a very individual thing, right? You know your strengths, you know your weaknesses, you know what part you need to focus more, what part. So you know a timeline, okay? You know a timeline in which you need to finish everything. So make a plan that suits you. Okay. The answer is 16 by 9. Okay. So is that correct? Devra Varun. Same to you. I hope your college is going fine. The RJ says mains are in 50. And I'm confused on how to go ahead at this point. So at this point, it's all about practice. Practice. Work on your speed and accuracy. At this point, just quick revision and speed and accuracy. Okay, that's all the motto that you should have. Okay, RJ, you can keep attending these quick reviews series. Get your revision of the topic quickly and then practice questions on your own. Okay, solve mocks, solve PYQs. Okay, and work on your speed and accuracy. Okay, take time slots. 4 बार मीन्स है अब तो है यार लोगों को मौका मिल रहा है. So government had to do something, no? So it's just that they will say we have given you so many chances, now you can't complain. वो तो है, कंपटीशन तो बढ़ेगा. But ठीक है यार, वो I think on an average it remains the same. It doesn't really matter if it is 4 times or 5 times. On an average, you realize the amount of competition will remain the same. It's just that now the luck factor, because earlier, trust me, in my day, we used to get only one chance. Like, so if I'm having a bad day, then my result gets screwed, which happened to me. Okay, on I had a bad day, that's why I got a bad rank. Okay, maybe not a bad rank, but worse than what I had expected or what I probably deserved, let's say. So if I had 4 chances, then over that 4 chances, that factor of the day would have reduced. Okay, you having a bad day factor would have gotten neutralized. Yeah, it's correct answer, sir. Actually, it's JEE Advanced question 2020. Yeah. So don't worry. Okay. Like practicals are in March and pre-board. हाँ, pre-board भी announce हो गया भाई. ये तो रहेगा. That too many skip Jan attempt because of practicals and would get one chance. Yeah, I know. In my time, there were no 2 attempts also. There was only one attempt. Okay, so obviously, let's see. So you know this. Okay, so what you can do about this is, so work done in isothermal process is nRT times ln V2 over V1. So it will be ln 4. Correct. Now, for work done by adiabatic process, adiabatic, I already know it is nR delta T over 1 minus gamma. Correct. So now, since this is 1 mole of helium, so helium is monatomic. So since this is monatomic, I know what gamma would be. Gamma would be 5 by 3. Correct. So here, what you will realize is that this will be nR delta T over gamma minus 1 would have been 2 by 3. So this is what you would have had. Correct. Now n is 1. I envy these people. I feel relieved that I'm not into the one match at the same time. Yes, I know. It can be really tough. The pressure is definitely going to be more big, and plus, in my time, okay, fine. So there was a disadvantage that you had only one attempt, but after that one attempt, you were free. So you were mentally relieved. Now there is so much pressure of having four attempts. So yeah, I know the pressure would be higher. Pressure would be higher, definitely. Okay. So now here, what I know is I can also write this as 3 by 2 V2 V2 minus P1 V1. Correct? Because I can replace NR delta T as this. Now, similarly here I can write this as PV also. So I can write this as PV times ln4. Correct? Now on the second hand, P1 was 4V. So obviously P1 कितना हो जाएगा? P1 would be P by 4 because PV would be constant, right? Okay, and since V2 is 32V, what will P2 be? So again, uh, because you can relate. So if I can find P2, then I can substitute these values and have the answer, right? I know. नहीं सबकी 99 तो नहीं आ पाएगी ऐसा भी नहीं है. Now I can apply the adiabatic gas equation, so I know P1 V1. Okay, I hope you know this because initially, here it was P comma. So here the pressure would have been P by 4. Okay, so that is how I wrote that for adiabatic process. We will start with pressure of P by 4 and volume was 4V. Now you realize PV to the power gamma is constant, so I can write P1 V1 P1 V1 to the power gamma equals P2 V2 to the power gamma. So what I can write is P by 4 into 4V to the power of 5 by 3 would be equal to P2 times 32V to the power of 5 by 3. Right. So what you realize is that P2 would come out to be P by 4 into 1 by 8 to the power of 5 by 3. So 1 by 3, 1 by 8 to the power 1 by 3 will be 1 by 2, 1 by 2 to the power of 5. 1 by 2 to the power of 5 would be 32. Correct? I hope I am correct in that. So this would be P by 4 into 32. Okay. Now with these values, I can substitute here and I can finally find this. So this would be okay, with a minus sign. So I should have had a minus sign also because it's 1 minus gamma. So this would be this. Now I can substitute this. If I substitute these values, I will get minus this time P2 V2. P2 V2 would be PV by 4 minus PV. Correct? So what you realize is that here I'm getting 3 by 4, so my 9 by 8 PV. Okay, so 9 by 8 PV here and here I have PV ln4. So now this, if I substitute my values here, so W iso over W adiabatic would be PV then 4 over 9 8 PV. So this and this gets cancelled. ln4 can be written as 2 ln2. So this will be 16 by 9 ln2. Okay. I hope you followed this. Okay, Devra, are you fine with this, Devra Varun? So go through the solution once. Go through the entire solution once. So this is how we started, right? And just go through it once. We are getting 16 by 9. Okay, so Moisha says, and in fact, I am gonna look at this lecture for Looking onto Carnot cycle. What they explained was crap. Okay. All right. So just go through the solution. Okay. And I hope you followed it entirely. Okay. This is how you would have solved this. All right. Okay. Okay. So should I move on? If you have noted this down. Okay. Make sure you followed the solution. All right. All right. Great. All right, now let's talk about any general polytropic process. Okay, so any general polytropic process can be represented as this equation P V to the power R is constant. But, okay, this is how you can represent any process in general. In general, okay, you realize here the R is called the polytropic index. So polytropic process means any kind of a variation on a PV graph. So in general, most of the processes can be represented as PV to the power R. You will realize if R is so if I have PV to the power R equals constant, so you will realize if R is zero, what kind of process am I looking for? Isobaric process it becomes, correct? Now if R is 1, then you realize that this becomes isothermal. If R is gamma, then this becomes adiabatic. Correct. Now, similarly, after you will complete the session, I have a doubt. Clear that. That's not from this chapter. Okay. So we will just cover this general polytropic process, then a couple of questions, and that is it for today. That is all that I've planned for today. Then you can ask your doubt. And what you will realize is that if I can also write this as p to the power of minus or 1 by r. So if I take r root, p to the power 1 by r, p equals constant, I can also write it like this, correct? So if r is infinite, then what you have is isochoric process. You just realize all the processes you just studied can all be represented as PV to the power some R equals constant, where R is called the polytropic index. Now you can have other processes also with other values of R. Okay. Now for any general polytropic process, you will realize the work will come out to be this. Okay, I mean the integration is exactly the same as adiabatic. Just instead of gamma, you put R, so obviously the integration would come out to be like this. So W is like this. You also know that for any polytropic process, U is n CV delta T because it's a state function. So for any polytropic process, what you will realize is Q is equal to n CV delta T plus n R delta T over 1 minus R, and this can be written as NC delta T, where C would be called the molar heat capacity of any polytropic process in general. That from Meridov Mechanics, question number 132, 138. Okay, I will take that up as soon as I finish this. Okay. So what you realize is, okay, so here I've written that this is how you can write delta U, and if I want to define the C or the molar heat capacity for any polytropic process, then I use the first law. I say Q equals delta U plus W, and when I get that, this is the relationship that I have for C of any general polytropic process. Okay. So this is how you can find the molar heat capacity of any general process. So as I said, you can have infinite values of R and hence infinite values of C. All right, now let's get started with a practice problem. So here you've been told that when a system goes from state A to state B, it is supplied with 400 joules of heat and it does 100 joules of work. Now option A says the change in internal energy of the system is 300 joules. The change in internal energy of the system is 500 joules. If in moving from A to B along a different process, the system works 400 joules and heat absorbed by the system in this process is 700. And D says both A and C, and E says both B and C. So which of the options is correct? Quickly try this. Let's have a quick practice problem, and then you can solve other problems also. So I'm starting with this easy one only. Okay. So you're taking a system from A to B, and you realize it is the delta Q is 400 joules, and the work is 300 joules. So obviously, change in internal energy is 300. And that should be clear. So option A obviously is correct. Right. Now the change in internal energy of the system is 500, so this is incorrect definitely. Now, if in moving from A to B along a different path, the work is 400, the heat absorbed would be this. That is also correct because you realize that delta U will remain the same. So if the work required is 400, then the heat required would be 700, 400 plus 300. So this is very easy. So A and C, both A and C are correct. Option D is your answer. Okay. Option D. This is a very basic. Okay. All right. This is easy to see only. Okay, family home. I don't think you'll need that much of time. Okay. Now let's give you a slightly tricky problem. Yes, D is the correct answer. Okay, so let's take up a slightly tricky problem. This says the temperature of 2 moles of a monatomic gas is increased by 300 Kelvin in a process uh, which is represented as P proportional to V. Okay. Then you have to find the molar heat capacity of the gas. It is 3R. The heat required in the process is 1200 R. The molar heat capacity of the gas in the process is 2R. Both A and B, both B and C. Okay, so try this one. This is slightly different. Okay, so try this one quickly. And then you can practice more problems. Okay. The general approach should be clear. Sorry. Again, I told you this is a general polytropic process. So for a polytropic process, I've told you how to calculate everything. Okay. So if you can find the molar heat capacity, then you can solve all of these. So Deepak Gosai says, Rohit bhai, kaisa hai? Okay. So who are you, Deepak Gosai? I'm not sure if I remember you. Okay. So Yarji says, sir, there are topics which I somewhat know and topics that I have zero idea about. What should I go for first? So if you can name the topics, then maybe I can guide you better. Because there are some topics which are not worth starting from scratch now, and there are some topics that you want to, master. Okay, so what are the topics that you have some idea about, and what are the topics that you have zero idea about? If you can tell me, I will be able to guide you better. Okay. So how about this family home? You're trying this? Are you trying this problem? So let's say this will be probably the last problem that we solve, and then we will move on to family homes doubt. Problem 138. So I had solved this one in my in my special class. Okay, family home. I told you, you can on the app. I have special classes where I've been hosting, Erudov solutions sessions for Erudov solutions, where I've discussed this. But I'll show you quickly again. Okay, I'll quickly show you again also. Don't worry. There in that problem discussion session, I've already solved this. So in future, as I told you, you can attend those sessions. So every week I am having because people requested, sir, वो mechanics discuss करा दो थोड़ा सा Erudov का. So I have been taking sessions on discussion of mechanics problems. Okay, don't worry. I will solve this one also. Okay. So all you need to do is realize. I'll give you a hint. You have to realize that P can be written as some K times V, or you can write P V to the power minus 1 equals K. So R in this case is minus 1. The polytropic index is minus 1. None of the options are matching. Oh, okay, okay. We will get that sorted. Don't worry. First, let me get this sorted. Giving me trouble. Okay. So here the polytropic index is minus 1, right? Unknown ray optics, EMI, AC, rotation, COM, inertia, probability, 3D. अरे बाप रे बाप, इतने सारे अननोन कैसे हैं? ओके, EMI एंड AC मैंने अभी लिया था इस पे, ठीक है. I have taken very recently on the YouTube. Okay, you can watch those videos for class 11th. When for class 12th I have taken EMI and AC. वो देख लो, EMI and AC छोटे टॉपिक्स हैं, ये जल्दी से हो जाएंगे. ठीक है, so I would advise कि ये टॉपिक्स तो कर ही लो, अननोन भी है तब भी. ठीक है, you can watch my lectures. Yes, absolutely, absolutely. Yes, you are right, family home. That is how you would have done that. And Baki is just mathematical manipulation slightly. So I would suggest EMI and AC आप कर लो. ठीक है, रे ऑप्टिक्स एग्जैक्टली, रे ऑप्टिक्स थोड़ा बहुत या 10th में भी पढ़ा होगा, 12th में भी पढ़ा होगा. सो रे ऑप्टिक्स, इवन इफ यू डोंट ट्राई टू फोकस राइट नाउ, यू वुड हैव सम मेमोरी ऑफ रे ऑप्टिक्स. रे ऑप्टिक्स थोड़ा बहुत आसान क्वेश्चन एटलीस्ट मेंस लेवल का शायद हो जाएगा. जो नहीं हो रहे होंगे वो एडवांस लेवल के होंगे. सो डोंट वरी अबाउट इट. अगर तुम्हारा बेसिक अंडरस्टैंडिंग रे ऑप्टिक्स का 10th का 12th का ओके है, तो मेंस लेवल के हो जाएंगे. डोंट वरी अबाउट दैट. EMI and AC are small topics. You can watch my lectures on EMI and AC for class 12. They should help you. ठीक है ना. And center of mass and inertia जो है, rotation, ये लंबे टॉपिक्स हैं. सो मे बी रोटेशन एक बार को यू कैन स्किप ऑल टुगेदर, बिकॉज वो टॉपिक समझने में बहुत टाइम लगता है. ठीक है, यू प्रॉब्ली डोंट हैव दैट काइंड ऑफ टाइम. सो व्हाट यू कैन डू इज you can go for COM. Definitely center of mass समझ लो. Center of mass is important. Okay. Yes. NCRT अभी करो. Exactly. NCRT कर लो and you will be fine for mains. Okay. अभी focus should be mains. So again, I would say you can leave rotation out. Moment of inertia calculation उसमें बस focus कर लो. In rotation only focus on moment of inertia calculation and center of mass again पढ़ लो. ठीक है. थर्मो सम आइडिया यू ऑलरेडी हैव. थर्मो कर लो, थर्मो इंपॉर्टेंट है. ओके, सो ऑल आई वुड से इज जस्ट इग्नोर द टफ पार्ट्स ऑफ रोटेशन, बिकॉज वो समझने में बहुत टाइम चाहिए. ओके, रे ऑप्टिक्स एनसीईआरटी से कर लो, योर मेंस वुड बी ओके. ठीक है. EMI and AC, you can watch my lectures. Rotation, you can skip. Just focus on, in rotation, just focus on moment of inertia calculations, because they generally ask one question about moment of inertia calculation on every paper. They have been asking. Center of mass पढ़ लो यार. Center of mass important concept है और वो बहुत जगह यूज हो जाता है. Okay, that is my advice to you. I hope that helps. Alright, let's get this. सर अगर एंगुलर मोमेंटम के रिस्पेक्ट में सोचें तो जैसे जैसे स्ट्रिंग सिलेंडर में बढ़ेगा, वैसे वैसे उस डिस्क का स्पीड बढ़ेगा ना? नहीं 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 नहीं, ऐसा नहीं है, ऐसा नहीं है, ऐसा नहीं है. I'll tell you why. I'll tell you why. Okay, and first let's solve this. So R in this case is -1. I already know the molar heat capacity of any general topic polytropic process can be calculated as this, right? Okay. फिर से दिक्कत दे रहा है. Oh, so hang on a sec. Software has been giving me some issue. Okay, so general uh, process का polytropic index ऐसे आता है R over 1 minus R plus CV. So I know it C would be equal to R over 1 minus R plus CV. So since this is monatomic gas, so monatomic का जो CV होगा, CV I already know. So this will be R over 1 minus minus 1, and CV I know is 3 by 2R. So this would be 2R. Okay. So C for this process is 2R. Also, sir, please tell the team to update the playlist. SHM and waves playlist are missing. Okay. 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 We will discuss that. So this option is correct. This option. Okay. Molar heat capacity is not 3R, it is 2R. Now, heat required. Heat required, obviously, Q is NC delta T. So, N was 2, C I calculated as 2R, into delta T was 300. Correct, delta T was 300. So, Q will come out to be 1200 R. Correct. So, this option is also right. So, options B and C are correct. So, option E is the correct answer. Got this? ये समझ में आ गया? ये इक्वेशन याद रख लो यार, बस ये इक्वेशन याद रख लो. आर ढूंढो प्रोसेस का और बहुत सिंपल हो जाता है, फिर इतना आसान है सोल्यूशन. ठीक है. ओके. नाउ लेट्स गो टू योर क्वेश्चन, है ना यार. फैमिली होम, लेट्स गो टू योर क्वेश्चन. आई हैड अ कपल ऑफ मोर प्रॉब्लम्स फॉर प्रैक्टिस, बट वी विल स्किप दैट. Okay, maybe we will start the next session with that. So problem number 138 that you have asked from Irdo is something like this. कुछ ऐसा सिचुएशन दे रहा है. If you watch the top view, so there is a cylinder. Okay, there is a cylinder of radius capital R, and from this cylinder a string has been attached, right? So to some light colors. So string has been attached like this, and at the end of this string you have a disc. Okay, disc A, and this has a length of L naught. Correct. And now you've been told that this is given an initial velocity V. Correct. And you have to tell in how much time it will strike the cylinder. कोई नहीं होता है. यही कह रहा हूँ, स्पीड एंड एक्यूरेसी का एक बैलेंस होना चाहिए. पेपर अटेम्प्ट करना है सही से तो वर्क ऑन दैट, वो बहुत मैटर करेगा. आती हुई चीजें गलत कर दोगे. ओके, नाउ व्हाट यू रियलाइज इज दैट यू आर राइट. The force that is acting on this, so suppose after some time the string would be like this, और इतना string wrap up हो गया और ये ऐसे होगा. So what you realize is that velocity will always be perpendicular to the string. Okay, so the string never does any work. Correct, ये बात समझ लो. If you got that, then it is fine. So what you realize is I can say, since the force of tension is always perpendicular to B, therefore it never does any work. Hence, the kinetic energy and the speed are constant. Now, when you're talking about angular momentum, the issue is that about which point are you calculating the angular momentum. If you take the angular momentum about this point, you realize about this point the tension is creating a torque. About this point, the tension is creating a torque, right? So that is why the angular momentum is not constant. Okay, in fact, the torque is opposite to the velocity. The velocity is in counterclockwise. The torque of t would be clockwise. So that is why you will see angular momentum reducing because the radius is reducing. Okay, got it? हाँ यार ये फिर नहीं आया. मैंने इतना कुछ लिख दिया, आया ही नहीं कहीं. आज ये बड़ा दिक्कत दे रहा है. लेट्स होप अब नहीं आएगा प्रॉब्लम. Okay, so I can say all this. Now, the angular momentum is not constant because the tension does provide you a torque about its center. Now, ये point of contact जो है ये change होते जा रहा है constantly. Okay. The point at which the thread is touching the cylinder, that is changing at all times. Okay, that is why the angular momentum is changing. अभी समझ में आया? अभी भी lag है, अब lag नहीं होना चाहिए. अब lag नहीं होना चाहिए. At which point the screen is showing nothing written. About the center, if you're taking the angular momentum about the center C, then you realize about center C, the tension can provide a torque. अभी आएगा. You will realize that the tension can provide a torque about this. This is how T is acting, right? So T can provide a torque about the C point C. Okay. So tension can provide a torque about the point C, which is the center of the cylinder. So that is why the angular momentum is changing. Okay. The angular momentum is in counterclockwise direction. The omega is in counterclockwise direction, and the torque of tension is in clockwise direction. That is why it is reducing. अब इसको करेंगे कैसे ये समझ लो, ये समझ लो. Now let's imagine that this guy in small time dt, this moves here. Okay. So this is the extra length that gets wrapped around. So this is the extra length dr, small dr, that got wrapped around this. Okay. This distance would be v dt. Okay. Let's say that this guy is, the angle turned is d theta. Now what you will realize is that if I join these two, so this line also will get turned by d theta only. ठीक है भाई, ये सब समझ में आ रहा है? अगर यहाँ पे मेरा स्ट्रिंग d थीटा से रोटेट कर गया, तो जो स्ट्रिंग का जो कांटेक्ट पॉइंट था सिलेंडर से, वो भी d थीटा से रोटेट कर जाएगा. ठीक है, ये बात समझ में आ रही है? ये एंगल भी d थीटा होगा. करेक्ट. नाउ व्हाट आई विल डू इज अब थोड़ा मैथ्स में आते हैं इसकी. अब हम बोलेंगे कि I know d theta is equal to v dt, which is the arc length over r, where r is the length right now. R is this length right now. It is the radius in which the mass is rotating right now. ठीक है ना? अब मैं ये भी बोलूंगा कि जो लेंथ रिड्यूस होगी वो कितने से रिड्यूस होगी? r d theta. This length is the dr, and this can be related with capital R as, I can say also, minus dr. ये जो लेंथ रिड्यूस हो गई, दिस विल बी r d theta. करेक्ट. तो अब क्या करेंगे? d theta की जगह ये वैल्यू सब्स्टिट्यूट कर दो यहाँ पर. So what you will have is minus dr would be equal to capital R v dt over small r. Correct. Now it is very simple. What you have is minus r dr equals r v dt. ये सारे कांस्टेंट हैं, इसको सिंपली इंटीग्रेट कर दो. r कहाँ से कहाँ तक वेरी करेगा? L नॉट से 0 और t 0 से t. So what you have is L naught square by 2 equals R V T. So from here you have T equals L naught square over 2 RV. That is your answer. ठीक है भाई, क्लियर है? ये हो गया जी सॉल्व. ठीक है, जस्ट टेक अ लुक और ये समझ आ जाना चाहिए. ठीक है, ऑल आई हैड टू डू वाज आई हैड टू रिलेट जो एंगल टर्न हो रहा है उससे जो रैप अप हो रहा है स्ट्रिंग, वो रैप अप होने से रिड्यूस कितना हो गया रेडियस. ओके, ऑल राइट. एंगल्स को रिलेट किया स्पीड से और रेडियस से, और फिर उसको डिक्रीज इन रेडियस से रिलेट कर दिया मैंने. ओके, और आंसर आ जाएगा. ग्रेट. ऑलराइट, सो ये वी विल स्किप एंड दिस आल्सो वी विल स्किप, दिस आल्सो वी विल स्किप. So I think we have run out of time for today's session. So it's time to end the session for the day. And again, software seems to be troubling me. All right. So that brings us to the end of today's session. And before I leave you, let me remind you guys that if you haven't gotten your Plus subscriptions and you are planning to, this is how you do it. Go to the Plus section of the app, select your goal as IIT JEE, and click on the Get Subscription button. All right, when redirected to the payment page, do not forget to use this code RDLive. This will give you a 10% off on all your subscription fees. Okay, now you can choose from two kinds of subscriptions, Plus or Iconic. And when you click on Proceed to Pay, you can choose a no-cost EMI option that suits you best. Okay, now you can also go for the Iconic subscription. This will take you JEE preparation to the next level by assigning you personal coaches and giving you these extra features along with your regular Plus features. Now you have combo subscription offers also available that you can go for. So you have a combo where you get Iconic for JEE and Plus for 11th and 12th. Now you can go for a combo where you get all three Iconic. Okay, so if these subscriptions have been clubbed together and the combo subscription turns out is cheaper. So this combo subscription takes care of JEE Plus boards. So if you're looking for complete preparation of JEE Plus boards, you can go for this combo subscription. Okay. And of course, you could have gone for all Plus subscriptions or Plus for JEE and Iconic for boards. Okay. All right. Absolutely. No problem, family home. All right. Now you can also win yourselves these subscriptions by taking part in the Next Gen Academy Combat, which is happening tomorrow. So remember to compete in that live, get to know your standing amongst your peers also, get to test your knowledge, and if you do well, then you can win yourself some really cool rewards. You can enroll using this code RDLive. All right, and then if you like today's session, then don't forget to press the like button and share it with as many people as you can. As I told you, the Unacademy also is providing you free quality content for those students who can't afford these subscriptions or have other reasons too. I don't know. So if you don't want to take the subscription, you still have a chance to get free quality education on this channel, and make sure you're promoting this to make it reach other people also who might need this. Okay. Now, if you're new to this channel, you can subscribe for more amazing free quality videos on different lectures here. And don't forget to press the bell icon to keep receiving notifications of all these sessions happening here. PDF of all these slides that used in today's lecture will be available for download very soon. Those of you who are following on this channel, do not forget you can connect with us on the Telegram app using this link. So that will make sure that you are getting all the notifications and you are aware of all the sessions happening on this particular channel. Okay. Now, with that, I will take your leave. But before I leave you, this is my code. So, if you like my lectures, if you'd like to join my Plus courses, if you'd like me to mentor you through your IIT JEE journey, you can get yourself the Unacademy subscription using this code RDLive. This will give you a 10% off and, of course, unlock all the plus benefits for you. So, with that, I'll take your leave. We will continue our discussion on thermodynamics tomorrow. Okay, so till then, you guys keep practicing hard, keep studying hard, and Happy New Year once again. And I'll see you tomorrow. Take care of yourselves. Bye bye. Oh, okay. That's all right, Lokesh. All right, we are. Yeah, I got it. That's all right. That's all right. But that's the advantage of the online study, no? You have it recorded now. You can watch it later also. All right. So you watch it and take care of yourself. Bye bye.